Kashyyyk is the forest-covered planetary homeworld of the Wookiees, and is one of the more iconic planets within the Star Wars universe. But is it even possible for a planet like Kashyyyk to exist? Hey everyone, my name is Matthew, at least when translated into Galactic Basic, and in this video we'll discuss whether a so-called jungle planet like Kashyyyk could be out there in the universe. And if so, how to world build a planet like it for yourself. So, without further ado, welcome to the World Building Corner. Alright, let's do this. Kashyyyk, according to Wikipedia, is a temperate jungle planet that has no axial tilt and a perfectly circular orbit, causing it to lack seasons. The center of the planet is covered with a tropical ocean belt, which contains a number of islands and large coral reefs. The remainder of the planet is covered in the unique Roshia trees, which average 300 to 400 meters in height. Though supposedly deep within the forests, a variety of Roshia tree can reach several kilometers in height. Let's really quickly break this description down. Firstly, in climatological terms, a jungle is a description, not an actual climate zone. Jungle simply refers to any area of land covered with dense forest and tangled vegetation, usually within tropical climates. The actual climate classification of Kashyyyk would be a rainforest, which, as we determined in our video discussing how to world build rainforests, is a humid climate zone with trees that form a dense closed canopy. Specifically, it's the high humidity present throughout the climate zone that's required for rainforests to form and survive. Based on the descriptions provided in Wikipedia, as well as the visual representations of Kashyyyk within the movies and TV series, Kashyyyk certainly fits this description. Rainforests also have little to no seasonal variations, with every month having similar temperatures and rainfall. The axial tilt of a planet is called its obliquity, which refers to how tilted the planet is compared to its parent star. The higher the axial tilt a planet has, the greater the variation in seasons. The lower the tilt, the less variation in seasons. A planet's orbit simply refers to its path around its parent star, and how circular the planet's orbit is called its eccentricity. An eccentricity of 1 means that the planet's orbit isn't a circle at all, while an eccentricity of 0 means that its orbit is a perfect circle. Just like with axial tilts, the higher the eccentricity, the greater the variation in seasons, and the lower the eccentricity, the less variation in seasons. With an axial tilt of 0 and an eccentricity of also 0, Wikipedia is correct that the weather on Kashyyyk would be very similar all year round, with no seasons, which, as we discussed, is perfect for rainforests. Next is where we start to enter some questionable territory. Kashyyyks tropical ocean belt is an excellent zone for evaporation to occur, and therefore have high levels of humidity. Which is great, except that across the equator, wind is effectively non-existent. The intertropical convergence zone is a band of low pressure across the equator, where there's little to no wind. On Earth, it's these conditions across the equator that allow for humidity to settle, and therefore for rainforests to thrive. On Kashyyyk, based on its description, there are a number of islands within these equatorial zones that would absolutely be a rainforest climate. The questions start to arise, however, when we move away from the equator. With the humidity from the tropical ocean belt effectively stuck there with no wind to carry it away, non-equatorial climates would need other bodies of water to evaporate as sources of humidity to form rainforests. Otherwise, Kashyyyk would look less like this and more like this. Based on the picture provided of Kashyyyk on Wikipedia, it does look as though there are non-equatorial sources of water, so this might not be a problem. Except for wind not allowing the humidity to settle. On Earth, we also have non-equatorial oceans, but our planet isn't covered in rainforests. One of the reasons being because our wind zones move water vapor around too much. Our average water vapor in Earth's atmosphere is around 0.4%, and rainforests sit at around 10 times that, at 4% water vapor in the air. So, a planet that's covered in rainforests must have at least close to 4% average water vapor across its entire atmosphere. One way that we can achieve this is by slowing the rotational speed of the planet down. If a planet like Kashyyyk were to rotate at around half the speed of Earth, increasing its day length to around 48 hours, then it would lose all of its wind zones except the intertropical convergence zone and the tropical easterlies, both zones that rainforests can exist in. Assuming sufficient evaporation, water vapor across the planet could theoretically be high enough to be suitable for rainforests everywhere. As on Earth, rainforests that exist within the tropical easterly wind zones are required to have hardier trees to accommodate the winds and storms present in the areas. Though, based on the description of roshier trees, Kashyyyk already has this problem sorted. This slower rotational speed presents a new problem though. With such long days, temperatures would be unbearably hot during the day and drop to be frighteningly cold at night. Such extreme temperature swings are, unsurprisingly, not very friendly to life, and at the very least would make rainforests unlikely to survive. One of the simplest ways of addressing temperature differences like this is to increase a planet's atmosphere. Having a thick atmosphere increases the greenhouse effect on the planet, which in turn makes temperatures more homogeneous across the entire planet, rather than warm equatorial zones and cold polar zones. It also means that heat from the day would be trapped for longer within the atmosphere before being lost at night. Just be careful not to put the planet too close to its star, or else it'll start to cook like Venus. Functionally, by increasing the thickness of the atmosphere and reducing the wind zones, we're recreating the optimal humidity and temperature conditions for rainforests across the entire planet. A planet like this might not be 100% covered in rainforest, but it would be covered enough to consider the planet a rainforest planet. Whether a planet like this could even exist in real life is obviously unknown, as we haven't found any other life-supporting planets besides Earth. But if you're wanting to world build one that makes sense, this is the direction to go down. So, to recap, a planet entirely covered in rainforests like Kashyyyk would need a very low axial tilt and eccentricity to prevent seasonal differences across the planet. For rainforests to thrive away from the equator, oceans are required as sources of humidity. And to keep that humidity around, planets can rotate slower to reduce the amount of wind zones, and its atmosphere can be thicker to increase the greenhouse effect and keep the planet at a more homogeneous temperature. You can learn more about how to world build rainforests as well as other biomes in our step-by-step world building series. And you can find all the information for this video as well as other resources for world building in general over at worldbuildingcorner.com. And if you enjoyed this video, don't forget to like and subscribe to follow the world building journey. And until next time, stay awesome.